Hello students, in this video we'll see an example of a telescopic series which involves three terms. Let's find the sum of the convergent series n goes from 1 to infinity, of 1 over n times n plus 1 times n plus 2, right? And we know the series converges by comparison with p cubed, right? So this converges by comparison with n to the -3, right? This thing is definitely going to be smaller than that, okay? Good. And it's not negative. So what we're going to do is use partial fractions. So let's use partial fractions. So I know that 1 over n times n plus 1 times n plus 2 is going to be a over n, because they're all linear, plus b over n plus 1 plus c over n plus 2, right? Okay, that's great. And so now how are we going to find n? So we can just combine like terms over here. This is going to be a times n plus 1 times n plus 2 plus b times n plus 2 plus c times n plus 1, right? All over what we want, n times n plus 1 times n plus 2, right? And so I equate this to 1, right? So of course, let's gather the like terms over here. So I'm going to have an n squared. N squared is a factor of a, right? And then a b, and then a c. So a plus b plus c has to be 0. Let's look at the coefficient of n terms over here. So this, of course, is going to be n squared plus 3n plus 2. This is going to be n squared plus 2n. And this is going to be n squared plus n. So what's the coefficient of n going to be? The coefficient of n is going to be what? It's going to be 3a plus 2b, 3a plus 2b, and then plus what? And then plus a c, plus c. And then the constant term is going to be what? That's the term we care about. This is all over n times n plus 1 times n plus 2. And then the constant term over here is going to be what? I'm going to have 2a, right? And there's no other constant term, so I have a plus 2a over here, right? So 2a has to be equal to 1, right? So 2a is equal to 1, therefore a is equal to 1/2 over there. So a is equal to 1/2. Now I have a is equal to 1/2. I know that 3 times 1/2, that's a, plus 2b plus c, plus 2b plus c has to be equal to 0. And then I also know that b plus c, and then b plus c, and then plus a, which is 1/2, has to also be equal to 0. So these equations are going to simplify to what? These equations over here simplify to b plus c is equal to -1/2, and then 2b plus c is equal to -3/2, right? So now what I can do is the following. I can do the negative of this equation. So I have negative b minus c is equal to +1/2. Add these equations together, and I get that b is equal to -1. So b is equal to -1 over here. Great. So now I have b is equal to -1. And then finally, we can use these equations to solve for c, right? And so what will c be? So I know that if b is -1, this equation over here tells me what? This tells me that -1 plus c is -1/2. Therefore, c is equal to +1/2, okay? So our expression over here is really what? Our expression is really going to be 1/2 over n, and then minus 1 over n plus 1, and then plus 1/2 over n plus 2 is equal to our expression, n times n plus 1 times n plus 2. Of course, when n is equal to 1, what does this term become? When n is equal to 1, this term is exactly going to become what? When n is equal to 1, I have a 1, and then a 2, and then a 3, right? So it's going to be 1/6. So now let's write this in the following way. I'm going to write this in a little bit of a clever way. I'm going to write this as 1/2, and then a 1 over n minus 1 over n plus 1. That gives me half of the n plus 1. And then minus 1/2, 1 over n plus 1. That gives me the other n, 1 over n plus 1. And then minus 1 over n plus 2. Those terms will cancel over there. And so now our sum becomes this telescopic sum over here, right? So in other words, we have this telescopic sum. So I'm going to define bn to be 1 over n. So let's define bn to be, let's do it like this actually. Let's define bn to be 1/2 1 over n minus 1 over n plus 1. then our series is what? Our series becomes Bn minus Bn plus 1. So our series over here is the sum, n goes from 1 to infinity, of Bn minus Bn plus 1, right? And of course, the Bn terms are tending to what? The Bn terms over here are tending to 0. So we're just going to get what we get when we plug in n equals 1 over here. So in other words, this is going to telescope. This is going to be a B1 minus B2 plus B2 minus B3 plus B3 minus B4, et cetera, et cetera. See, all the cancellation occurs. All those terms cancel. We're just left with a B1 over here. So the sum just converges to B1. Of course, because the Bn are tending to 0, right? Because the Bn, if you look at them more carefully, they look like 1/2, and then I have an n plus 1 minus n. So it's going to be a 1 over n times n plus 1, like so, like that. And now, of course, I see that these terms are tending to 0, so the terms at the end of the series go to 0. And of course, what is B1 going to be? B1 is going to be 1/2 times 1/2. So in other words, the series converges to 1/4. So our sum over here, our original series, converges to 1/4 by using this telescopic sum trick, which basically involves solving a system of 3 equations and 3 unknowns for a, b, and c in the partial fractions decomposition. Thank you very much.